वही हो गया तो उसके बाद उधर चली गई। तो मुझे देखने का छोटा सा फुल स्क्रीन करता है। So good morning everyone. दुर्गेश जी इसको म्यूट आपके फोन में ऑन है। Power is there. I think some extension board I also installed in the yesterday. Yes. Okay, so as I think you all have your breakfast. Yes. So now if you have your breakfast, then you are able to work. Yes. Or to stay here for from 9:30 to 5:30 or 6. Okay. So today, what we are going to discuss, as I said, you already have your breakfast. Yes. Right. So when we are talking about the precision agriculture, okay. So the main thing is food of the precision agriculture. Okay. So the food of the precision agriculture is data. Like so, so you can see from this image, we have two left and right side. Left side, we are doing the manual seeding and all the labor intensive. Another side, we have a data intensive futuristic farm. So with the help of data, we are able to use the precision agriculture method. So we here it is written as well. Precision agriculture is a powerful tool, but it is also a data hungry. Okay, so it means if we want to perform anything on the basis of the idea of precision agriculture, we need some data. Okay, so for the data, what we need to do? So in the yesterday class, we also discussed about the different mechanism with the data set. Like we have a remote sensing data, we have a yield map, we have a historical data, we have a UAV data, we have a historical data as well. Yield maps. So different data set we have. With the help of data set, we can apply the AI, ML, and deep learning techniques to assure the automation of the agriculture by serving the resource utilization. So in this, what we are going to discuss as precision agriculture, right time, right place, right amount, and right time, right input. Yes. So four things: right time, right input, right place, and so with these we can perform the precision agriculture. So if you want to learn something with the precision agriculture, we need three things first: the observe, analyze, then act. Okay, first we need to observe, then analyze, then act. So what is important today? Today is important. First we need to observe. So today is our focus to observe the data. Okay, so for the observing the data, so what we are going, so if somebody is a farmer, those who are working in their field in the real time, they are doing the farming, so we can say if they are an expert, okay, they are an experienced observer. So with the human eye, means what they are getting from their human eye, they are getting RGB data only. From the human eye, we all are getting the RGB from 400 nanometer to 700 nanometer, 750 nanometer. Beyond this, we are not able to see, or someone is are able to see beyond the 750 nanometer. Okay, so that means when we are having an experience with the farming, so we can, from the human eye, the very basic thing that the health, growth, and vigor. So with the help like these things, on the basis of the human eye, we are just assuming our human eye is having a original color interpretation. On the basis of the color interpretation, we are saying that if it is a green agriculture, then we can say it's a healthy vegetation or healthy agriculture. If there are some yellowish or some like red or some different spot and the circles like this, so we can say it's a slightly unhealthy style. Okay, so with this, if we want to observe not only with the human eye, we have to go beyond that. Yes, because only the human eye is not sufficient to analyze the data in depth. Okay, to go this, what we need this type of sensor. So in the first, it is a satellite, like the we are seeing the our atmospheric or like our earth surface from the air, from the space. Okay, and the second is the farmer's eye from the space, like a UAV. Okay, then third is the we have a farmer's nervous system. There is a nervous system, like we have IoT sensors, we have a devices. So when we have this, and the last one is the farmers, the previous year data, like historical data, previous year yield map, other different of meteorological data, the previous year data. So that is a notebook of the farmers. So on the basis of when we are combining these, we are getting a smart farm. Okay, when we have this kind of facility, we can say our farming is a smart farming, modern farming, or precision agriculture followed farming. Okay, so what is important when you are going to discuss about the data? Like in the previous slide, what we are saying, the satellite, we can go with the farmer's personal eye like a UAV. Okay, the nervous system like sensor, IoT. So different mechanism we have, but we have to select the accurate or optimized platform. Okay, so what is important? The first is platform. It depends on your end application. What is your end application? So according to that application, we have to decide the platform. Then after the platform, what information you are expecting from that platform? You are talking about the satellite. So what type of satellite data you want? How much resolution you want? So another thing, the data, how much data you want? Then type of data. You want a multispectral data, you want a hyperspectral data, you want a panchromatic band. So that is our objective. And then how much the frequency. You want regular basis, you want 5 days, you want 10 days, 15 days, month wise. So that is the important when you are dealing with these farmer's eye from the different place, like the space, personal eye, and the nervous system. So we have these category of the data when we are talking about the precision agriculture. So what categories we have? We have agronomic data like soil type, yield data, and crop scouting. Then environmental, the weather station data, humidity, rainfall, precipitation. Then remote sensing data, like we have an image. Okay. Production data, that we have yield maps, harvest records, prescription data, like when we are going to seed, fertilizer application plans, then the management data, or we can say the historical data or yield map. So these are the different categories that we need to consider when we are going to the precision agriculture. What is our objective? So as per like, what is our platform? We will go with the agronomic data. So we have to go with the some website. We have a remote sensing platform. So that we need to decide. Then what is your objective? According to your end application, we have to find out the information. Clear? So first we will go to discuss the remote sensing. So how many of you heard about this word remote sensing? Okay. So remote sensing. This is a remote. Can we say it's a remote? Or it is sensing something from here? Yes. I am going to touch here. No. I can move and I can play and pause and next to previous. Yes. So remote sensing is that we have to capture or acquire the data remotely without its physical touch or without its present location as well. If I want to collect the data from the Madras, I need to go there Madras. I can collect from the satellite as well. Yes. So that is like we have to use the remote sensing. So we can say it's a space eye of a farmer if we are talking about the agriculture domain. Or somebody is interested in soil, somebody is interested in irrigation, somebody is interested in water. So we can say it's a human eye or the farmer's eye of the precision agriculture. So we have this type of remote sensing in our planet, different sensors, UAVs, airborne system, satellites. So these are the planet that we have in our Indian scenario as well as the world scenario. Yes, as I discussed already, that our visibility is 400 nanometer to 750 nanometer. Beyond this, so from this visible eye, what we are getting just color information from the agriculture. From the color intensity, we are measuring that this crop is healthy, this crop is slightly healthy, this crop is unhealthy. If there is a pure green, we are saying it's a healthy crop. If there is something like yellowish or some red, so we are saying it's a unhealthy or slightly unhealthy. So with the help of visible or the visible range of the human, we are getting this basic information. But if you have to deal with the 100 kilometers, 200 kilometers farm, what you will do? Is it possible by the human eye only? So that we need some add-on things so that we have some like this is our range from here. Blue we can see, green, yellow. So like 400 to 700 nanometer we are able to see. Beyond this is the part of the actual agriculture. Okay, like we have to go with the beyond 700 nanometer. Then we are able to find out the deep information from the crops. Okay, so for this, like we have to go NIR band, that is a multispectral band. Then we have to go the hyperspectral band. On the basis of this visual range, we can collect the data. So this is how the satellite is capturing in their swath and the path. So they are getting the continuous images on the basis of different resolution, temporal, spatial, spectral, radiometric resolution. They are getting the data. We have two types of sensors. So all you have active sensor or passive sensor in your eyes. Passive sensors you are having. When there is a dark, then what you will do? There is a dark room and you want to see something on that room, what you will do? Yes, you use some torch or some flash. So that is again the active or passive. Yes. So suppose today, is there anything that we need to especially like you are using any torch or something else to see this presentation? No. When we are in the night, what the energy source is there? There may be a moon if there is no cloud or okay. So like we have two types of sensor in the remote sensing, the passive and the active. So in the passive sensor, what we have like the natural resources, okay, like our moon or our sun. We are getting the energy from this, and the energy will directly incident on our earth surface and captured by the satellite. And then we have active sensor also. Yes, if you are using, yes sir, please come. So when you are having your phone, okay, there is no light or dim light maybe. So what you will do, you just open your flash and then you are able to capture the data. So you can see from this visualization, like sun rays are coming to the earth and the satellite is capturing, and this is our ground station that we are downloading data from the satellite on. So the reflection, absorption and the transmission in the light, and then we are getting the data from the earth surface by the satellite. So what we are collecting the data using the satellite. So we have, if our satellite is having a sensor, like we are able to collect the data in the form of forest, water, grass, bare soil, paved road and built up area. So everything we are getting with the satellite. Okay, so we need to that we discussed, like we have to find out the end application on the basis of the platform. Okay, so the end application and platform, our application may be forest, maybe grass, maybe soil as well for agriculture point of view. Yes, so that means we are just, the sun is coming in the earth and we are some reflected radiation, satellite is capturing that and we are downloading them directly. So this is again like we are getting the tree, we are getting the water, grass, bare soil, pavement and built up area with the help of satellite data. So this, like the human eye, we are getting only the RGB. Beyond the RGB, we have to use the satellite. Like we have to go the infrared, near infrared, ultra micro. So that we need to go with the satellite. So most of the cases, when you are purely dependent on the crops, your agriculture is, sorry, your research is totally related to the crops. So most of the time, the multispectral band is sufficient to find out some research and research objective. Till multispectral, you are getting much and more information. Okay, so we have this, like we discussed the satellite and how we are getting the data from the satellite, how the satellite is getting from the earth. Okay, how we are going to download the data. So on the basis of different, as you know that we don't have any only one satellite, we have a multiple satellite. Yes, some are open source and some are commercialized. Okay, so we have 4 types of resolution. On the basis of the resolution, we will decide our end application and the target area and the total entire area of interest. So we have 4 types of resolution: spatial, radiometric, spectral and temporal. 4 things is important for your research. Like you have to choose your platform and the data on the basis of these 4 resolution. Okay, so we will discuss one by one. These 4 resolution is very important as you are discussing about the remote sensing, because on the basis of this resolution you are able to select the right input, means right data from the satellite. Okay, so first we discuss the spatial resolution. I think you all know about the spatial resolution. Spatial resolution, it means we have a pixel information. Okay, so every satellite is having a different spatial resolution. Okay, so spatial resolution, so here you can see I selected a one small pixels. So the area is, total pixel is 100 square. It means the pixel size is 10 by 10. Okay, so the satellite is capturing the information per pixel 10 by 10. Okay, so this is a spatial resolution. Then we have to go with the radiometric. So the radiometric resolution is the intensity, that some of the data is stored on that pixel, that we already know that spatial of the pixel, and then we need the information from the pixel. So that is a radiometric. So you can see the 8-bit image, 16-bit image, and this on the basis of, if we are having a 2-bit, we are getting a low resolution, 8-bit medium resolution, 16-bit high resolution. It means we are having a number of shades. So if we are having a 4 shades, it means data is low resolution. We are having a 250 shades, data is maybe high as compared to the previous, and the 65566, we are having a more resolution shades on the radiometric. So these spatial, radiometric, and then the spectral. So spectral bands, I think you know spectral bands. That's RGB is also a band, red, green, and blue. Yes. So that is the same. The spectral information, like the spectral bands on a particular satellite. How much band the satellite is having? 1 band, 2 band, 3 band, 4 band, 6, 8, 9, 10, 11, 12, 13. So that is the main objective. Like we have to go with the spectral resolution. So a spatial resolution, it means what it will give you? Information about the pixel. It means the resolution, it's a high resolution or low resolution. If the pixel size is 10 by 10, if the pixel size is 1 by 1, which one is high resolution and which one is low? 1 by 1 is high resolution. You are getting a 1 pixel in 1 square by 1 square. Okay, so you are getting a more information. If you are having a 10 meter by 10 meter, you are getting a low resolution data. Okay, so Now the spatial, then radiometric, number of shades on that particular pixels. So if we are having a number of bit is high, 2 to the power 8, that means we are getting 256 shades of that particular pixels, then 2 to the power 16, 24. Okay, so it depends like how much bit image we have. Then the spectral resolution. Spectral resolution, number of bands. So suppose we are talking about the general camera, your mobile camera RGB band we are having. Multispectral, it means the NIR and red edge we are having. So 5 bands we are having. Hyperspectral, 100 of bands. So these are the spectral resolution. Then the temporal resolution. That is a very important. The temporal resolution, it means the revisit time of a satellite on the same place. Okay, because we are talking about the agriculture. Agriculture is not only the 1 day program. It's a 4 month, 6 month program. Okay, we have to analyze a crop at least 3 to 4 months. If there are some not, we are talking about the vegetable only. We are talking about the specific crop like wheat, sugarcane, rice. Okay, so that we have to follow the season. So this is the temporal resolution, like how the satellite will come again on the same place in how much days? 2 days, 3 days, 5 days, 6 days. So there is a revisit time on a particular space by the satellite. Okay. So these are the 4 resolution. What are the 4 resolution we have? Spatial, radiometric, spectral, temporal. So 4 resolution is important to select a satellite. By choosing a open source or the commercial satellite, you have to go with the resolution. Okay. First you check the resolution of a particular satellite, then you have to decide this end application will able to perform or not. Okay. So these 4 resolution, on the basis of these 4 resolution, we have some satellite data, like different satellite we have. So here we are going to discuss the freely available data set. Okay. So there is a one satellite, that is Sentinel-2 program. This is a ESA program. So Sentinel-2, how many of you know about the Sentinel-2 data? One. Okay. Sentinel-2, it's a satellite which is launched by the, which is launched two, or we can say the two satellite parallelly, 2A and 2B. Okay. Both are in different date. You can see there, the 2A launched on 23 June 2015 and 2B launched on 2017 after 2 years. Okay. So that when we are having this only 2A. Okay. So the revisit time, it means which resolution? Temporal resolution. So when we are having this 2A data, so the same satellite on the same place will come after 10 days. Okay. When we are having a 2B, so we are getting a 2A along with 2B, means we are having a, now as we can say, we have two satellites in the Sentinel-2, but they are like they are doing with the parallel thing. So now we are getting the data in 5 days. Clear? Okay. So the spectral resolution with spatial resolution. So when we are talking about the resolution, as I told you that you have to select the satellite on the basis of the all 4 resolution. If you are having the information about the 4 resolution, then you need to select. So every, what the Sentinel-2 is having different bands. Bands is related to which resolution? Spectra. Yeah. So spectral resolution. So if we are talking about the normal camera, so we have 3 band only. This satellite is having a multispectral band as well. Yes. So this, like, not only the 5 bands, beyond the 5 bands we have. So some resolution of the, like, 10 meter, sorry, some bands are on the 10 meter, some bands are on 60 meter or 30 meter. Okay. And then radiometric resolution is 12 bit. Is it high resolution or low resolution or medium? 12 bit, 2 to the power 12, high resolution. So now I told you earlier that if we are having only 2A, the revisit time is 10 days. Yes, but now we have 2B as well. after 2 years. So the revisit time is 5 days. Okay. So this is the information, like how we are going to the spectral bands with their resolution. So spectral, spatial. So the spectral band, suppose we have a aerosol, blue, green, red. So you can see this is our working bands that we need to do in the agriculture. Okay, 10 meter, 10 meter, 10 meter. Clear? So this is very important for us, RGB band. Then what we need to do, NIR. So NIR band we are getting again 10 meter. Okay. Then you can go with the red edge. The resolution is changed. Yes. So it means the spectral bands, according to the spectral band, we are getting the spatial resolution. So we have how many bands in Sentinel-2? 12 bands. Okay. So these 12 bands is not only for the agriculture, some other purpose as well. Okay. Someone is interested in the water, so they can go with the water band. Someone is interested in vegetation, they can go with the vegetation. Someone is at aerosol, so they can go with this. So this satellite will provide you the compact application for different purposes. Okay. So this 12 bands we have, and please remember these things, very small things that you need to answer in your quiz. Okay. Very small things that you have. We have a one quiz. Okay. So 12 bands we have. Okay. So uh, now we have to move the another satellite, open source satellite, which is we can download this data. This satellite is openly available. Today we will discuss how to download the data as well, and we are also going to download the data and process the data in the next session. Okay. So then we come to the Landsat. Second satellite is Landsat. Okay. So Landsat data, launch date is 27 September 2021. Okay. So Landsat 8 and Landsat 9. We have Landsat 8 and Landsat 9. So before 21, we have Landsat 8. Okay. From 2013. Okay. So Landsat 8 or Landsat 9, both are similar kind of band information. So same like launch date we have, spectral resolution with spatial resolution. So some bands are not 30 meter, some bands are on 15 meter, and some band 100 meter as well. So which one is having a high resolution? Sentinel-2 or Landsat 8 or 9? Yes. Yes. Sentinel-2 is having high resolution. Yes. From the back, Sentinel-2 or Landsat? Yes. What do you think? So in the Sentinel-2, what resolution we are having? A special resolution 10 meter. Yes, for our interested band is RGB or NIR or red edge, the 10 meter. What resolution we are having? Starting is 30 meter and 15 meter. We will give the band information as well, but I am just asking a question. Sentinel-2 is high resolution or Landsat 8 high resolution? Sentinel-2, clear. This is another question. Okay, so then we have a temporal resolution. So when we don't have this this Landsat 9, what we are having Landsat 8 data set. So when we are having a Landsat 8 data set, then the revisit time is 16 days. But now what we are having from 21, Landsat 9. So the revisit time is half. So 8 days we are getting the MS same. So temporal resolution is high with the Sentinel-2 or not, or low? So which one is better than for agriculture purpose? Okay. Then radiometric resolution. What bit we are having in that Sentinel-2? 12. Here we are having. So which one is good? Landsat, you are having a good one. Okay. So yes, I think we didn't discuss the specific use in agriculture. So crop health monitoring, stress detection, field variability analysis, crop classification, fertilization. So in the same with the so as you know that the revisit time of Sentinel-2 is 5 days and the Landsat 8 16 days. and the Landsat 9 is 8 days. Yes, you are getting. We have two data set in Sentinel 2A and 2B. Okay, Sentinel 2A revisit time is 10 days. But now we have another sensor merging with the Sentinel 2A is the 2B. So now the revisit time is half of the time. So 2A and 2B giving the data in 5 days. Okay. Similar, we are having a Landsat 8 data in 2013. So we are getting the data in 16 days. But now we have a Landsat 9 from 21. So we are getting the data in 8 days. Okay. So this, it is like long-term change analysis. So if you want to check the vegetation in 16 days, or we can say in a month, 1 or 2 times. So we have to go with the Landsat 8. Land cover mapping. So pixel is information is good in Landsat or Sentinel? Sentinel. How much are saying that Sentinel only? What about others? Okay. Again, we will discuss one satellite, so you will get. So this is a like 9 Landsat 8 that we already discussed. It is launched on February 2013. Before this Landsat 9. So Landsat 9 and Landsat 8 having the different beat with different multispectral, hyperspectral, panchromatic band. So the temporal resolution with, as I already told you, 16 days. Yes. And the radiometric is 12 bit. What we are having now? 14 bits improved. And Sentinel 2, we have 12 bit. So Landsat 9, we are having a much number of states as compared to this 8 and Sentinel 2. Okay. So this is the band information, like the band, the spectral bands with their spatial resolution. So most of the band we are getting out 30-meter resolution. Our interested band. Okay. We are interested in blue, green, red, near infrared. So we are getting in the 30-meter resolution. That is lower than Sentinel 2. Okay. Then another satellite is Planet. So Planet, what we are having as per the, like, I think someone is know about the Planet. So the Planet scope is a one satellite provider. So if you want, it will give you the very high resolution data. High resolution. So the meter will decrease or meter will increase? Decrease. So our, as per the Landsat 8 and the Sentinel 2, Landsat 8 is giving 30 meter. Landsat 8 or 9 is giving 30 meter. Sentinel 2 is giving in 10 meter. So definitely it will give you the less than 10 meter. Yes. So this Planet scope is giving the spatial and spectral resolution with the 3 to 4 meter. Okay. So it means we are getting a 1 pixel into 3 by 3 or 4 by 4. Okay. So the spatial resolution is very less in this 3 to 5 meters that we are getting. And the temporal resolution is daily. Spatial is high, temporal is high, radiometric, similar to the Landsat 8 and the Sentinel 2. Okay. And the specific daily changes if you want to see what the daily changes. So it depends like what type of crop you are selecting. Okay. So these are the like, but the thing is that from the Planet scope, if you are a academic students, researcher, it is a commercial satellite actually. Okay. But if you have a institution like affiliation with the institution, academic institution, you can download it freely as well for a 5,000 kilometer. Okay. So it depends like if you are you are in different organization in the academic institution, so you just need to register first and they will activate your account and you have to select the area of interest. So you can download the data in 3 to 5 meter resolution. Okay. So as most of the people are saying that the data is very crucial, or data is if we want the high resolution data, we need to pay something. So there is no need to pay something. It's a freely available for the students or the teachers, those who are working in the research field. So you have to direct login with your academic mail ID and you are able to download the high resolution data in freely basis. Okay, so as I think you are if you are doing to research, so you have to decide your area of interest. Like you will decide for the Jabalpur, you will decide for the Uttarakhand. So a specific area you have to decide. So that is sufficient for the research purpose. So high resolution data you are getting a freely, and the daily data set we are getting. Okay. This is the band information. We have a RGB 3 meter, 3 meter, yellow, red edge, or NIR. Both we are getting the 3 meter resolution. So this data can be useful for our agriculture purposes, which is very high resolution in all. Like we have a good temporal. Yes, temporal resolution is 1 day or regular basis we can say. Spatial resolution we have 3 meter. Spectral bands we all are having, the important bands we are having. Then the radiometric. So we are getting the 4096 shades on a particular pixels. Okay, so the 4 satellite. So one I already discussed, like 3 from the open source, and one is also the commercial for those who are doing the commercialization purposes. But you are the researcher, so you can download freely. Okay, so these are the 4 satellite is very important, so that you can start your research. Okay, so high resolution data set you have and the low resolution as well. Okay, it depends. So if we want to cover a larger area, which satellite is good? Larger area we have to cover Landsat. Yes, but the resolution is very low. Yes, so most of the time if our study area is 5 kilometer or 10 kilometer of farm, so we can go with this planetoscope. Okay, so 4 satellite is clear. Okay, with the resolution as well. Other satellite we are also having the Cartosat 1, 2, and 3, which is Indian satellite. Okay, so you can download the data with the academic institution mail ID freely as well. Okay, so I worked on these 4 data set, like the Sentinel, Landsat, and the Planetoscope. Okay, so they are sufficient to start your research and complete the research as well. Okay, so this another one is the MODIS. Very few people are using this MODIS data just because of the, this is also open source, just because of the what we are having. We are having 1000 meter resolution, 250 meter resolution, 500 meter resolution, spatial resolution. What we are having a 3 meter resolution, and we are having a 250 meter resolution. Yes, so if your objective is entire India, then you have to go with this, because it is not possible with the Sentinel-2, because when we are going to collect the data using the different satellite, definitely sometime there may be a cloud, some atmospheric error there will be there. So with this, like we are having this kind of satellite, the MODIS. So the MODIS launching date is 1919, or then Aqua we have 2002. These are the different bands that we discuss in the next slide. Temporal resolution is daily for global. Radiometric again 4096 we are getting, so 12-bit image we are getting, and the specific large area vegetation monitoring. Okay, drought assessment, global crop forecasting. So if we are talking about the yield estimation of particular India, then we have to go with this type of satellite, because with the Sentinel it is very difficult. If we are going to download the Sentinel-2 data, it will take too much time to download the data and then process. So it may be the season will be end. Okay, so that is the main reason that we have to go with the large scale satellite. Okay, so these are the band information what we are having, this different bands. So B1 we are having, these are the band name, the B1, B2, B3. So 250 meter, 250 meter, 5 meter, 500 meter. So this our interested band, this NIR band, what we are having 500 nanometer. So too much like information in a single pixels. Yes. So these another one satellite. So that if you have to download the data of Sentinel-2, so what you need to do, that today we perform the hands-on on this. So we have to open this Copernicus Open Access Hub. It's a free registration required. Okay, and you are able to download the data from the Sentinel-2. Okay. Yes, sir. Another one is Landsat 8 and Landsat 9. So we have to download with the USGS Earth Explorer. You can download the data from directly from the USGS Earth Explorer. These are the steps which is you have to follow. And today we will do this session. Yes, so the format of the downloaded data file is GeoTIFF. Okay, so we discuss what is GeoTIFF. So, and the next is MODIS. So MODIS you can download with the NASA Earth Data Search. So you are able to download the, it is also free, or we can say it's not free, it's open source. Then PlanetScope. So this is a paid or commercial satellite that you need to, if you want to download the data. So this Planet Explorer will give you the registration. You have to register your account with your mail ID. But be clear, if you are doing any research with the remote sensing GIS, please use your academic mail ID. It will give you the full access. Okay. This is our Indian platform, Bhuvan platform. So you can download what we are getting directly with our Bhuvan portal. We are getting directly NDVI map. Okay. So suppose somebody is interested to publish the NDVI map. They are interested of a particular area or shape. They need to just upload the shape file and they are getting the NDVI map of particular location with the help of. So Bhuvan is providing the ready-made product of NDVI. Okay, so with the help of NDVI product, you can analyze your crop by the chain management, by the day by day changes in 7 days, 5 days. Ma'am, NDVI is a normalized difference vegetation index. So the normalized difference vegetation index is a mathematical formula. NIR minus red upon NIR plus red. So what we are doing, we are just minus the NIR band to red band and then plus the NIR band. And then we are getting a new map or new band we can say. So this is the NDVI map. Yes. So the NDVI map values varies from -1 to +1. So if you are getting a 0.2, it means the NDVI value is low. So your vegetation may be a low health. You are having a NDVI value 0.5, it means that your vegetation is approximately okay. Then you are having a NDVI value 0.6 to 0.8. It means you are having a healthy vegetation. In agriculture, ma'am, we are having the change detection. Okay, because we have a satellite in the revisit time, 5 days, 10 days, 13 days, or 1 days as well. So change detection we can check, like the NDVI with the health assessment we can do. Okay, so these are the basic, but it depends how you are going to select. Suppose you want to find out the change detection. Okay, like you are following the 5 day satellite, the Sentinel-2, but there may be a possibility in the next 5 days you are getting an image. After next 5 days, there may be a cloud on that particular image because it is an open source. So we cannot complain to them why this is cloud. I'm not interested in cloud. So that is the main thing. You have to change detection. So what we are going to do, we are applying the generative AI on that particular satellite image. So we are going to generate a new image by the previous and the next one. So suppose we have a today is 28. So we have 28 data and then we have 1 data, 1 November data, and then 6 November data. And 11 November don't we have, but we have 17 November. So what we can do, we can generate from this chain and we generate a new image. So that is a generative AI. So madam will discuss you how to generate a new image. So different application with the land use, land cover, and suppose you are interested to classify the entire crop. Suppose our industry, like we have to go with the yield estimation, we have to measure the GDP. Ma'am, yield estimation is small area is practically possible. For small area, we can go with the district wise. Yeah, district wise we can go, but if you go beyond the district, then you have to check with this. Because only the NDVI, sorry, this satellite image is not sufficient for the yield estimation. You have to check the historical data, yield map, meteorological data, So these are the basic things that you need to do. So suppose you don't have the soil data and you are predicting the yield of a particular area. So that is also some unfair with that particular agriculture land. Okay. So for a small area that as per my experience, uh, I have taken the Haridwar district, entire Haridwar district for area estimation for this sugarcane and the wheat field. Okay, so what I did, I collect the data from the Sentinel-2, some of the data from the Sentinel-2, and some of the data from the PlanetScope of same places, and then go some manual sites, and then fly our UAV, and then calibrate all these three data, and then analyzing the NDVI first. If they are having a similar kind of NDVI, I'm not saying that the actual similar, because UAV is very high resolution, Sentinel-2 is low resolution, and Planet is also very high resolution. So we are getting a different NDVI, but we are checking the pattern. If the pattern is matching, then we need to classify the entire area in the same things. So suppose we are getting a 0.25 this, 0.25 this, 0.25 this. So we can classify as a wheat. So the knowledge based classification. So like I think it's a very deep in the remote sensing. So there is a one software NV. So ENVI, it's a paid software, a commercial software, where you can apply the deep learning and machine learning on your knowledge based. Means there are already model available. You have to just apply your knowledge. Ma'am, approx 5 lakh. Yes. So NV and so these are the different softwares. So but they are paid. So most of the time those. Yes, ma'am, that QGIS is available. Right now, QGIS more features like Python. We can import the libraries. We can import the some small deep learning and machine learning model. And if you are able to pay, then go with the Google Earth. Sorry, ArcGIS Pro. ArcGIS Pro license is very 6,000 or 7,000 for a academician only if he is a student. So it's very they are having a direct deep learning and machine learning model. You just need to click and click and click and just provide the data and they will give you the entire information. So India Bhuvan portal we have. Durgesh, time. So the precision agriculture that we already discussed. Now come to the UAVs. So I think we study class we discussed the different payload time with the fixed wing, rotary wing, and the hybrid. The payload time, maneuverability, best use. Uh, yes, so these what we are having the pros and cons with the multi-rotor, fixed wing, or single rotor. Okay, so if we go with the multi-rotor UAVs like we have a hexacopter, octocopter, and quadcopter. So flight time is very comparatively is small as compared to the fixed wing and single rotor. So single rotor, you can see the Kedarnath Yatra. Yes, most of the time they are using a single rotor only. So these different UAVs we can have and the different limitation and pros and cons we have. So for the multi-rotor, most of the time we use the aerial photogrammetry. Photogrammetry like we are reading the grammar of the photo. So aerial photography or photogrammetry, we have to use the multi-rotor most of the time. When we have a LiDAR or laser scanning, like we have a very high altitude, then we have to go with the single rotor. Ma'am, that may be a one reason, but right now we have it's not costly right now, I think, because 8 to 10 lakh we have a LiDAR sensor and you can configure with your UAV and you can scan the data. So like most of the peoples are doing with the LiDAR scanning. Right now, ma'am, most of the time, it depends on the resources. It's not about the cost only. Suppose you have a UAV, but you don't have a pilot. Okay. Suppose you have a UAV, but you don't have any permission to fly your UAV there. So some resources are there, but the optimization is still missing. Like government is having a different policy, but nobody is knowing about that. Yes, so that is the main problem. I am just discussing about the basics, like different types of UAV brands that are available to purchase. Okay. So the DJI, that is banned in our India. We cannot purchase the DJI drone. Okay. Just because of it's a China product. Okay. But the capacity of the DJI is compared to the other drones is very high. They are doing very well. Okay, so these are the different drones. I used this Phantom 4 and the Mavic Air. Both I used when they are not banned. Okay, so in the starting phase I used. Then we have a Parrot. It is a certified drone. So we can have a Parrot drone. It's a rotary wing drone. So different drones have a different maneuverability, speed, and what we can say the battery timing, or that is the endurance, how much time they can fly in the sky. Okay, so on the basis of difference they have, and you can see they are using a GLONASS GPS. So means we are getting a point centimeter accuracy. Means if I am here, I am getting the same location. So very precise information we are getting from the drone. Okay. Some Autel, Skydio, Unique. These are the paid drone actually. So what we are able to do the real-time data availability. Yes. When the Trimble and the same the brands of the UAV. Which one, ma'am? UX5? UX5? Ah, okay, no problem. So, but as per India, we have an Idea Forge. Okay, it is an Indian company, Idea Forge, that we are using like one drone from the Idea Forge as well in my lab in IIT Roorkee we have. So that we can use. That is a. I think I discussed the rule regulation about the DGCA in the previous class. The DGCA certification, type certification, pilot certification, but that is not required for you people. Okay, it's a commercialization only. If you are using a drone for the commercial purpose. Okay, if you are doing for research, there is no pilot license is required. Permission is only required in the red zone. Sorry, ma'am. Ma'am, if you are doing your research, then only permission is required in the red zone. Green zone, you can fly directly without pilot license, without certification. That is that means in my PhD, I have a training, I have a pilot certificate. All I have, but no one asked me till now. I flight like Chhattisgarh, Haryana, Punjab, and Kedarnath as well. We have all the data in the video and image format. The multispectral, hyperspectral RGB data we have. Okay. Yeah, that. So I think it may be there may be some GPS fault, ma'am. That may be it's like it's a like not a technical glitch. There may be a malfunction, as we can say it's a satellite based. So when I yesterday I told you, if you are going to fly a UAV, at least check first you have 7 satellites in your remote. If 7 satellites is not connecting with your remote, then you have to wait. So if I want to fly the UAV in this condition, we cannot fly because we are not getting a sufficient satellite. We will get only 1 or 2 maximum in this cover area, but we can go outside definitely more than 7 to 13 satellites. So the minimum satellite is 7 that we need to collect. If I am able to connect the 7 satellite, then we can fly. Okay, there every ma'am, when you are dealing with this like UAVs and hardware kind of thing, there is a one possibility they may be crash because if you go with the like this company product, they will very high cost. Like if you are dealing with the multispectral camera, so the multispectral camera cost is 7 to 8 lakh. Then you need to purchase a drone. So if they are not providing any customization, so you have to complete drone you have to purchase. So it will cost you 12 lakh, 15 lakh, or 20 lakh. But you have to go with the assembling. So it is very cheap. So in the like 2 to 5 lakh, you are able to develop a one drone. by assembling the parts, and you have, yes, yes. So uh, these basic operations. So this is our fixed wing. So if we have to go with the larger endurance, if you have go to with the large area to cover, so we have to go with the fixed wing. This is developed by our lab, so we customize this by. So it's a total thermocol project. Okay. So it's a very lightweighted, more maximum 500 gram maximum. So it's a very low. There is a one camera below the here, so we are able to collect the data. Maneuverability is very low in this. We have to take a very deep swap from this. Another one is, ma'am, this is costly. This is like the camera is costly actually. 80,000 camera is there, and the cost of this drone is approx 20,000 maximum. So we have a one before this month. We have a one RC glider competition in our college. So total 28 teams participated in that, and we prepared a one drone. Sorry, this RC glider kind of this in 800 rupees. So we are doing in the cheaper and cheaper, and how the everyone can get us at least if the farmer is able to like invest 2,000 or 5,000, we can provide to them. That is our objective. But it depends, if you are going with the high resolution camera, the cost will increase. So we are just minimizing the cost with the drone as well. Like you just need the this thermocol seat and basic propellers. So it will easily you can adopt. This is our VTOL. So vertical takeoff, like we have a fixed wing along with the rotary wing we have. Ma'am, this is a two hexacopter and the quadcopter we have. So in this drone, what we are having, we are seeding the, okay, and it is a multispectral camera. This drone is with multispectral camera. So we are scanning the field. From this, we are just going to input the seed in the farm. This one, okay, and this is for multispectral camera. You can see. So we are capturing the data in the NIR and red edge band. Okay, that's good. Invite us, ma'am. We will train you. uh, that you need to develop, ma'am. So that's why you are here. We have a simulation session. You just join and you will fly, no problem. So then, as you have to download the data that is required with the UAV. That is very important. From where you get the data. So for the agriculture purpose, so we have a digital agriculture data collection, and so these repository will provide you the data that is related to the agriculture only, and they already work on that. They have a published paper, some patent is also there with their drone as well. So these are the public data set. Now you have to check this data is sufficient or useful for you or not. So these are the publicly available data set. So you cannot say that I have no data, how to start a research on the drone. Sufficient data is available in the internet, but you have to check. Okay. I will provide you this PPT so you can download directly. The link is available along with the paper and all. And then we have a Kaggle dataset, UAV based agriculture image dataset we have. So what we are having 924 images we have across 4 category. So fallow land, Indian mustard, rusk. So sufficient data for your agriculture research is available on the internet, which is related to the Sentinel satellite data or UAV. Yes, ma'am. Yes. Then UAV weed data we have. Some research repository, the Mendeley we have, the Walnut data we have. So this you can start your research and you can like follow the how the UAV will give you the high pixel or high resolution data set. This another data set, the banana data set, Hugging Face data set, drone based agriculture data set that you have. So they are specific like the cashew, cocoa, coffee images captured by the drones. and they already annotated. The main thing is that the data they have and they annotated the images. So that is useful. Directly you have to use the product. That another data set repository is the IoT sensor or the soil sensor data. So that is also one soil moisture sensor. So if we want to find out the drought in the soil, like what is the actual condition of our soil, so we have to put some soil moisture sensor on our field. So that we need to collect the temperature sensors. We have to analyze the temperature data of a particular field. So the temperature sensors we can help the humidity data, because I told you if you are going to predict the yield of a particular land, you have to also accompany these data. Only the image based you cannot say it's a yield estimation. You have to check these data as well. Okay. So the nutrient, pH sensor, light sensor for greenhouse. So these are the different sensor you need to the data. So these are the available repository. You can directly download the data. Yes, ma'am. Actually, we are working directly drone based. IoT sensor is not somebody is working on that, but we are working directly the Jetson based processing. Okay, so these are the some open source agriculture IoT sensors data you can download directly. So for your initial steps you can do. This is our our India and other US also providing some direct for a entire world for a specific area. Just as you like, suppose you are interested in Jabalpur city and you want some sensor data. So some private companies also install their sensor in different fields, because already someone is doing the yield estimation, some private agency, government agency. So this data is available in these government websites as well. So you can request to them and you are able to download as well. The Indian government portals. So for soil health card data, this is our Indian government website, the Agromat and the ICAR. It's a very known data set, ICAR. Then for the soil, so soil grids, I think those who are working already in the agriculture, so they know about this soil grid information. So this is the basic steps. So as we are getting the TIFF data in the satellite image, same kind of grids or all we are getting here as well. The soilgrids.org, dataisrec.org. The Kaggle dataset like open repository we have, so you can just, but you have to cite, as you have to follow the ethics, you have to cite their name or their publications. In the previous slide, we discussed the categories. So there is a one category is yield map and harvest. Like we are going to predict the future yield or something like the GDP of Indian agriculture. So we have to download the yield map as well. That are also available. The harvest report. So that is available in different website. The Open Agriculture Dataset, USDS. So these very important. Like when you are going to the precision agriculture, only image is not sufficient. Okay, you have to go beyond the image. If you are going to precise, if you are just a research objective for the precision, you are using the precision agriculture or you are giving the precision agriculture solution. Okay, both are different. So some other like how we are going to seeding fertilizer application plan, that is also available freely. You just need to follow these steps and the link and you will get the sufficient data from there. Some open repository for the agriculture research data. Now, in this slide, you can get most of the data along with the steps. Okay, and what is the purpose of data? What they already done, and what is the future gap or research gap? So this slide will help you to find some ads. In the previous class, someone asked me, can we go with the precision agriculture as a PhD point of view? So I think it's, I replied them, it's an online participant. Precision agriculture is not an objective, it's an opportunity. Okay, you have to, because everybody is doing the precision agriculture, but still we are facing some gaps because we are not doing in the unique way. Everybody is doing according to their availability. If he is having a soil sensor, he is doing on the soil only. He is not incorporating the UAV data, agriculture remote sensing data. So that is we need to do. Means the utilization or optimization of the resources. So that is the main objective of the precision agriculture. So that we can collect the data from their different repository according with the objective. So they will give you the, and there is some chatbot is also available. So if you ask them, this data is useful for me, but I want to do this kind of research, so they will guide you how to go with this research. Okay, means chat gpt is giving you the most of the thing, but this is a real information because they have developed something related to the particular domain. They are not a user specific. Okay, suppose chat gpt is giving to everyone using, everyone just putting their query and they are getting the answer. So it's a kind of human platform where everybody is getting the answer, but they are the very specific for the agriculture research. Yes, another thing is that those I earlier told you that if you are not able to download the satellite data, you are not able to store the satellite data, you don't know the GIS and remote sensing procedure, you can go direct to the Google Earth Engine. Okay, next tomorrow session we have at the Google Earth Engine, the hands-on on the Google Earth Engine, how to get the different these satellite that we discuss in this presentation, and how we are going to perform the different applications like the NDVI calculation and this OpenEU platform, the QGIS software. Today, this is our session. In the next class, the crop disease, some case studies that already someone is performed, and some case studies related to me that we already done. So the from leaf disease identification means they have the data and the final outcome and what they procedure they followed. So these are the some case studies in front of you. So what do you need to do? The simple, suppose this data you downloaded, this is you have, but you have to start in your own way. So what you can do, you just download the data, resize. If you are a CNN or deep learning you are going to apply, so these steps you need to follow for your precision agriculture related applications. Soil assessment, so soil data you already downloaded from different websites, and this you have to worry about that, as I told you that the right platform. So what is right platform now, as we are talking about the different agriculture product for the remote sensing? What do you think from this lecture? Which one is right platform for you? Okay, why I'm asking, from this you joined this FDP. So before joining this FDP, do you have any like small object that we will complete this object in this FDP? After this FDP, like we will learn something precision agriculture to disease identification, some remote sensing based classification, some object detection, stress detection, different index calculation. Anyone prepare this kind of mind map before coming to this lecture, before coming to this FDP? Yes, what do you have, sir? Hmm. Yes, yes. So as in the starting, told you that the main thing is that the precision agriculture is the food of the precision agriculture is data, and data is a right input and the right time. So with the help of right input, we will decide the right time. If suppose we are getting the agriculture data or remote sensing satellite data, and we are going to just change detection, like I think I showed you one slide in the yesterday lecture. There is some NDVI images, 0.5, 0.5, and 0.9. So the changes of NDVI in 5 days. Yes. So if you are getting a regular interval NDVI values 0.5, 0.6, 0.6, that means your crop is growing properly. Suppose I am getting a 0.5 to 0.3. There may be a something happening. Yes, there may be a some reason. So can we say that it is just the agriculture problem, or we can say that it's a calculation problem as well, or the data as well? Suppose I am taking the image from the agriculture using the satellite data, okay, and I am not able to download the data. That is a fun thing. Now I start to download the data. I downloaded the data, and after the downloading, I am assuring this the value is coming 0.5, and in the next day the value is coming 0.2. How it can be possible? It means we have to check the data, the downloaded data. Yes. So everything it depends on the data. You are not just saying, sir, I click on that particular website, I downloaded the data. There may be a possibility some pre-processing is required. We cannot use the raw data as well. Sometime we can use, but sometime raw information we need to process or we need to pre-process before going to the application. So after checking that you have checked the data is okay, the process is okay, definitely there may be a problem with the agriculture. Yes. So like these are the expertise. Yes. So from the human eye, we are not getting this. From the human eye, if someone is having a prediction on the basis of the human eye, definitely I will get uh, approx 100 kg wheat from this agriculture land. Is it? Is it possible? But in the previous day, someone is doing like this. Prediction. Yes, that is a prediction. So prediction again come to the remote sensing. If we have a previous year data, then we can predict for the next year data. But we don't have a actual data or right input, then the output will be the wrong. So it means we have a sufficient data with the verification. If suppose you are getting a soil data and get it from an Excel or CSV, somebody is downloaded 3 or 4 actual data and they just they just chat GPT that data set and they are generating a new data on the basis of assumption. What will be the output of that data? Because they are just 2 or 4 information on the basis of 2 or 4 they are just data 100 information. So there may be a possibility some error. So every time we cannot say that our method is okay, because agriculture is a very sensitive background. Agriculture, we cannot say if I am
Okay.
doing the same software and the same. So this is our objective. Like when we have a data, okay, we need to assure the data is okay. Okay, so for the assurance, what we need to do? Pre-processing is required. If required, then you have to learn how to pre-process the data. Okay, so these are the basic, but it is required. Suppose we are applying the augmentation. So augmentation, we have 4 images and you are applying the augmentation for 1,000 images. Is it right? Only 4 images and you are preparing a next 996 images. This is not a right way. Okay, so this can help you. This can help you to generate a data. This can help you to find out the some solution, but we cannot say it's a precision agriculture useful. This is for your like we can say it's a hit and trial. You just learning something. Suppose we don't have a UAV data, then you will not start to work. You will start to work. So you will find some data which is already available in the internet. So most of the time we are saying that we have to check the ethics of the data, check the privacy of the data. But the thing is that how we are going to check the data is okay or not. Suppose I uploaded a one repository, how you will go to check the data? This data is useful for our application or not. This data is verified or this data is following the ethical analysis. Okay. Another? Yes.
Okay.
So it So what we need to do, so when we are having this like the data, different data, satellite data, as I told you that there may be a cloud cover as well with the Sentinel, Landsat, because they are open source data set. So there may be a possibility the penetration of the sensor will not helpful to penetrate the cloud. So we are getting the atmospheric error and all. So before processing the remote sensing data, directly raw data, we need some pre-processing. So in the today's hands-on session, we will discuss how to pre-process the data before utilizing for application. So that is very important. In the same with the UAV, what you need to check? The overlap, because sometimes the UAV may be miss some information. So if we have a sufficient overlap, then there may be a few 0.1 chances there may be some gap or there may be some error in the UAV data. So these are the very basic steps, but you have to understand, because you are not doing a, if I am doing a research, I am not doing a very like this model will apply to the entire world. First we have to decide the data. If this data is okay, then we develop a one small model and then apply on a somewhere, and then we will go with the larger area. So that is our objective of the data collection. Yes, Durgesh. Yes, Shivam, you can ask the question. Hello. So now when we have a data, so if you are talking about the remote sensing data, so I told you that you just download your data. If you are downloading from the you like the verified website, definitely data is okay. But there may be a some after the opening the data, when you are open the data in your Google Earth engine or in your QGIS software, then you have to analyze the band information is there or not. In Sentinel-2, we have a 13 band, 12 band. 12 bands are available or not. NIR, our interested NIR band. NIR band is there or not. We are getting some pixel information by clicking on that pixels. If we are getting some pixel information, then our data is okay. Otherwise, if we are not getting any information from the pixel, then what we will do with that data? Yes, it's a blank form. Nothing we have, we cannot fetch anything from that data. So we can go with the manual pixel information. So you just click somewhere, it will give you the information, the pixel intensity. If you already calculated the NDVI value, you can calculate the pixel based index calculation as well. So you can go with the precise. Okay. Suppose you have downloaded some data from the internet. Okay. Then you need to check this data is okay or not. So what you need to do? First, you check this data is published somewhere or not. So, okay, somebody is already used. If they used, then find out the output of that particular data and then apply the same model with the same data and then check. If it is giving the same output, it means data is verified. Then you need to make some changes. There may be accuracy, maybe delay like 1 or 2%, but you can move. Okay, so these are some basics. But as a researcher, as you all know, we are a very confident about the research. We are a very much knowledgeable person. So we are just minimizing 2 or 3 things, but that is very important if we are going with the data set collection. Suppose you are saying that, sir, I am not a pilot, but I have a UAV data. So what you will do? Somebody is collecting the data and you are assuring them you have to collect in a right way, and he is saying, sir, I am collecting in the right way. Then how you will going to check? Because you are not a pilot, then you need to check. So what you can do, you just first open the image on your desired software like Google Earth, like ArcGIS. First check the geolocation on the map. It is coming on the exact location or not. If geolocation is deviated, there may be some GPS related issues in that software, in that drone. So there may be some error with that. Then we have to check the information, like the pixel information of a particular image. If we are getting some information, so these are the basic checks for the data, but it will give you the highest accuracy. Okay, suppose you already having a high resolution data set, then output will be the high. But you have to check this high resolution data is having some information on that particular pixel or not. If the visibility is okay, this RGB color is visible very fine, but we don't have any information inside that pixel, then the output may be varied. So it depends like what type of data and what we are going to use. Suppose we are interested in historical data. So you have to download from the government official website. If they are providing the, suppose we have this Sentinel data, so we have to go with the Copernicus. Landsat data, you have to go with the USGS because other repository is also there, but we cannot verify them because they are individual purpose. They use for them. So there are some websites, some repository, already verified repository we have. So we have to download the data from there and the basic operation. If you are talking about the remote sensing data, so you just open at that on that your QGIS, ArcGIS software and check the basic information, the geolocation, or we are saying the georeferencing of the particular image. If image is georeferenced, it means your data is downloaded for the area of interest. Because you are not able to see NIR or red edge image from the human eye. You cannot see from the this like human eye. So what you will do, you check the wavelength of the bands, like which wavelength is coming in this band. If it is more than 75 meter, that means there may be some near infrared. So these are the basic checks you need to assure before going to process the data. Okay, so now if we are going to the our mobile applications, so suppose somebody is interested to disease identification on the mobile data. So everybody is having a different mobile, yes, and the mobile is having a different sensors. The capability of the mobile is different, so they are capturing the data. Suppose you are taking a very like 5,000 or 6,000 rupees mobile camera, the efficiency of that image may be low with you are capturing from the 20,000 or 50,000 camera. Yes, so data always high resolution in high quality camera. So you are getting a more pixel information from that as compared to the 6,000 mobile data. So that you need to assure what sensor they are using to check this mobile data. So suppose somebody is mentioning that I am using the Android phone. Okay, that is not sufficient for us because Android we have lots of version in Android from 6,000 to 60,000 to 1 lakh or 2 lakh as well. In iPhone we have a different version. So first you assure the sensor is okay or not. If sensor is not okay, then we have to move for the next data set. So the sensor information, suppose somebody is saying that I have a multispectral camera in UAV, then check the version of the multispectral camera. It's a Mica Sense, it's a Parrot Sequoia, that you need to check. What sensor they are using, what data they are providing. So the proper information you have to identify. Because this Sentinel-2 data, this is official. But when you go with the open repository of UAV data, you have to check because nobody is providing the UAV data in the government officials. Most of the data is for some those who are working in the drone company. They are providing for the research purposes, just for the brand. Okay, just for the publicity. So you have to check which sensor they are using. They will provide you the information, the altitude, height of the camera. Suppose I am interested in the disease identification from the entire field. What height you may expect it from the UAV? Height may be low or height may be high. What do you think? We have to identify the disease from the agricultural land using the UAV from the RGB camera. We have to go 10 meter, 20 meter, 100 meter. 10 meter.
So what is the role of UAV?
Sorry,
Sir, what is the role of UAV drones in agriculture remote sensing?
what is the
Role of UAV drones in agriculture remote sensing?
okay. So roles of drone in remote sensing. So the first thing
Yes,
is that the data. Okay,
yes,
if we are getting the data, so we are having a multiple sensors, like we have a RGB sensor, we have a multispectral sensor. So on the basis of your application, suppose you are interested only the classification, so you can go with the RGB UAV. So you are able to classify the agriculture land. This land is for the sugarcane, this land is for the rice. So that is a one application. If you are interested to measure the stress of the agriculture. So you can go with the multispectral camera with the UAV. So multispectral camera will give you the NIR or near infrared or REGIT. So you can calculate the different vegetation indices. On the basis of vegetation indices, you are able to see the change of the agriculture. Then if you are interested to the forest fire, you are interested to detect the where is the forest fire. So you can go with the thermal or hyperspectral camera sensors. So these are the basic applications of the remote sensing by using the drone. And why we are using the drone? If our challenges is that we are going with the satellite. So suppose we are not using a planet scope one day, okay, then we have to wait at least 5 days, the open source data set, because the Sentinel-2 is giving you the 5-day data set. So we have to go wait for the 5 days. And how you can assure that disease will not coming in the next days? You can assure this like this. So it means we need to again and again recheck the our agriculture field. So the drone is best thing to check the data is coming regular basis, or we are not depending on the sunlight as well. We are not depending on the cloud. Suppose we are downloading data from the satellite, there may be a possibility of cloud, but we right now you can see in your back. So you can see there is no sunrise is there. There is no sun, but we can collect the data. But the satellite is capturing the data. There may be some cloudy weather. So because that satellite is 1,000 kilometer or 2,000 kilometer far from the earth, and our drone is 10 meter, 30 meter, 100 meter. So as per my experience, I flied my drone 100 meter as always. I fly my drone 100 meter. It's a standard for the agriculture purposes. But when you are dealing with the very small area, or you are interested for the disease only, then you have to altitude maybe a 10 meter, 20 meter, 30 meter. So there may be some like different sensors and applications. And I think we discussed this. Yield estimation, yes, that we someone is asking the yield estimation is possible. So they already done some work for the particular district they have performed on the basis of the different soil sensors, precipitation, pH values. So they have different data set. They are not observing only the image, because our today our focus is observe the data. Okay, so they are not focusing to observe the data in image format. They are taking the IoT sensor data, soil sensor data, and fertilization data, the that historical map, yield map. So they all are combining and then giving the yield estimation area. So that is like different open ML corn yield data set. So you can see here they are not doing with the entire field. They are interested on the single corn field. So it depends, like everybody is doing their research. So you have to optimize what is their objective according to their data, because there may be a possible if they have corn data, then definitely they will work for the corn only. So same model, same application, same method you can apply on your wheat data as well. Yes, but you have to pre-process what is required. Actually, that is our objective. So we have to go with the beyond the thinking that somebody has already used the con and what we will do with this data. Okay, so you just apply with what they are doing. They are just yield estimation. You just find out the classification method. So for the classification, you can classify by other images. Yes. How many of you performed some classification on deep learning? Not in the crop, any other fields? You all? Classification, you know? Classification? Like we are having a class A, class B, class C. Okay. So suppose in our agriculture land, we are scanning this agriculture land. So there may be a class. So can we wheat and rice in the same time? No? Obvious no. So we have to scan the data. Okay. So in that same time, what we are doing, suppose we have to classify the data from this agriculture land. And what we are doing, we have the data only the rice. In this time, we have rice and sugarcane and some other like the corn, or there may be some other fields. Okay, but I am interested only the rice as well. So what I will do, we cannot classify what we can or we can't. If you are waiting as a precision agriculture for the season, that is not good for the precision agriculture. So you have the data. If you have the classification data or you have the field data of the sugarcane, rice, wheat, you can classify multiple classes in the similar time. Okay, and then you need to apply the model on your season based. So you don't have to wait when the season will come for the rice, when the season will come for the wheat. You just apply your techniques on the data. Okay, we are not waiting for the seasons. We have the data, and according to the data, user can apply the applications. Okay, so these are the different applications. This is the yes, I discussed you that you can follow these steps by doing this. So the download, how the weather, soil, the management data, data cleaning. So that is important because you are downloading the data from somewhere. Okay, that may be a verified source or that may not be. So what we are doing, we are data cleaning we have to do. So on the basis of the data cleaning, future engineering, the NDVI, EVI, different vegetation index you can calculate for the agriculture health monitoring. So this is for the data source and acquisition. So what we learn in this class? The data source. So what are the data source? Satellite. We can say it's a remote sensing data. The phone is remote sensing or not? Yes, it's a remote sensing. So camera, we can say it's a remote sensing. So we can say sensor is a remote sensing. Yes, so sensor may be any sensor, like it's a camera sensor, it's a soil sensor. So we are getting the data from that particular field without touching or without visiting that field. So remote sensing data, we have different category, like we have a satellite data, we have a UAV data, we have a sensor data, then other, we have a mobile data. Clear? So, and then we have what category we have? We have 7 categories. What is the first category is? We have the one table in the presentation. So what we are having that slides? What type of data repository we have? Yes, that is the downloading before going to be remote sensing data we have. Then which category for the yield map? No. Category, we have discussed the 7 categories. You can see. So that is very important actually. So okay, so I think if you have any questions, so we can take from the data source and the acquisition, because after the T you have to perform this to download the data, process the data. So if you have any question, please ask. Slide, ma'am, when you have the quiz. Before the quiz, we will share. Yes, actually, we are just preparing a OneDrive, so where you can get all the data and the information as well. Yes, definitely we will do.
Sir,
So
how
any
can
question?
NDVI,
Ha, Shivam, please.
sir, how can NDVI be used to monitor crop health? What is NDVI?
You are talking about the NDVI?
Yes, sir.
The NDVI is normalized difference vegetation index. It will be calculated through the 2 bands NIR band, near infrared band,
Yes,
and
sir.
red band. That is available in all the multispectral camera. So if we are going with the multispectral like remote sensing, like
Yes, sir.
satellite data, the UAV multispectral MicaSense data. So there is a one formula NIR minus red upon NIR plus red. This is the NDVI formula. After this application of the formula, you will get the NDVI value
Yes,
from
sir.
-1 to +1. If the value is 0.5, your agriculture is optimum healthy. If the value is coming more than 0.5, your agriculture may be good or healthy agriculture. Is it?
Yes, sir.
Okay, thank
Sir,
you. Shivam, your voice is not coming properly to us. Shivam, I think network
Hello.
issue from your side. Yes, please. Okay, Shivam, just
Sir,
mention your
NDVI using irrigation management.
NDVI. Shivam, can you please paste your question in the chat box? I will reply on the chat box as well. Hello. Okay, so I welcome you all for the
Yes,
tea
sir. Yes,
break.
sir.
Please join us and I yes. Shivam, please paste your question in the chat box.
NDVI can use in irrigation management, sir.
No, no, no. NDVI is used
Maybe,
for vegetation monitoring. For the this irrigation, you have another indices.
sir, yield estimation, uh, sir, yield estimation output कैसे करता है ये?
Shivam, can you please mention your question in the chat box? So these are the
Okay, sir.
basic categories that
हेलो, आ रही है सर आवाज?
नहीं, एक
फोन
मिनट
पे
सर।
फोन
इसको बंद करो ना। फोन पे तो आएगी, उस पे देखना है।
सर इस पे नहीं आ रही है आवाज।
ओ, आप बोलो, आप बोलो सर, बोलो।
हेलो।
नो सर, यहाँ नहीं आ रही है आपकी आवाज।
इससे तो नहीं।
ओके सर,
इससे करें?
फोन कर लेंगे, कॉल पे बात कर लेंगे।
अभी कुछ नहीं करना करके ना, वो बोले इंजन का होता है शुरू में, इंजन हमें थोड़ी ना आता है।
हाँ वही तो कह रहे थे कि वो कह रहे थे
यूज कर रखा है, मैं बता दूंगी।
नहीं वो ठीक है लेकिन उसे डाउनलोड करने में टाइम लगेगा ना। जब वो कर रहे थे ना कि मैं तब तक अभी वो डाउनलोड कर रहे हैं Google Chrome
ये सब चीजें 2 घंटे में नहीं हो सकती, पता है जी, इसके लिए 2 साल में रखा है।
में। शायद मोटे मोटे डिटेल देने
वो सारा
तो
कुछ
उसमें है थोड़ा थोड़ा बताना सा, तो इसीलिए बस
कोई नहीं, हम 2 घंटे बता के चले जाएंगे, उसके बाद बताते रहना।
इसको नहीं बताना, मैं क्यों बताऊं? ये तो मुझसे बहुत-
जो बीच में मुंह बंद रहते हैं जब हम बोलेंगे अंजलि जल्दी
किस चीज के बारे में?
किसी भी चीज के
देखो एंटी टैक्स में तो बहुत दूर का मैंने पढ़ा ही नहीं, कुछ हो गया 2 साल पहले।
मैंने 4 6 7 साल पहले छोड़ देते हैं।
हाँ।
दिवाली से कब गए थे? 18 19 में।
होता ही नहीं है पता है।
ना तो फिर ध्यान
तुमने करना
करवाना।
आज मत बैठो जल्दी बैठ
टाइम माइक
ये कर दिया था। ये सर नहीं, फोन पे या इस पे नहीं आ रही सर।
इसको म्यूट कर। हेलो। गूगल अर्थ प्रो।
You can search. There is a fun first tab. Search. You can search your home place. Pradeep, you are able to. Pradeep, सुन पा रहे हो? Pradeep, hello. Pradeep. Hello, Pradeep.
वाईफाई ग्राउंड फ्लोर पे कनेक्ट है, यहाँ का भी है क्या वाईफाई लैब का?
कंप्यूटिंग लैब के नाम से मैंने बहुत कुछ
कंप्यूटिंग लैब ग्राउंड फ्लोर है।
हाँ लगा जो भी मिल रहा है
ग्राउंड फ्लोर
नहीं वो एक्चुअली वो नीचे से शिफ्ट हो गया होगा ऊपर इसलिए वो
अच्छा,
नाम
अच्छा,
चेंज
okay.
हुआ होगा
ग्राउंड फ्लोर वाला यही है। अच्छा,
चलिए यशोद जल्दी प्रदीप आवाज आ रही है? उसमें आ रही है जूम पे भी आ रही है ठीक।
ये वाला माइक
So Bhagyashree, you are able to hear us? Bhagyashree? Bhagyashree?
Yes, sir.
Okay. So now first you have to go your Google Chrome and type Google Earth Pro. You have to type in Google Chrome Google Earth Pro. Download Google Earth Pro. Download Google Earth Pro. Now you will get this screen. Okay. After this screen and the download, you are able to install. Please install the Google Earth Engine. Sorry, Google Earth Pro. How many of you installed successfully? Please raise your hand. Okay, thank you. Anyone left for the installation? Only 2 people. Okay. So wait for 2 minutes. Someone is also doing installation. Google Earth Pro. It will give you the high resolution visualization of your Earth surface. You can check by zoom in, zoom out. Pradeep,
yes sir
lots of voice are coming from your side. Okay, now can we start? Can we start?
Yes sir.
Okay, so from the online participants, so what we are going to do in this Google Earth Pro, it's an open source software. So first we will start with the basic GIS operations. So Pradeep, please start.
yes sir
So you have to see in both screen, you can see anywhere. So first you can search If you are interested for a specific area, you can search here. So he can search according to area of interest. Okay. So he searched the Roorkee, Uttarakhand. Okay. So you can see here we are getting this red mark highlighting the Roorkee area that we searched in the search box. Okay. Then first we start the three things. And the GIS we have point, line, and polygon. Okay, point, line, and polygon, three things. So first we want to, after this a specific area of interest, we have to mark a particular place on the basis of point, on the basis of line, on the basis of polygon. So first we start with the point. So please mark a one point by giving the information. So you can see in this Google Earth. Yes. Click on the point, marking a point. Yes. So after the clicking, Pradeep, just let us know how you are going this marking. Pradeep, from where you are getting this yellow mark? Yes. So what you need to do in the upper scale? Wait. In the upper menu, you are getting some yellow kind of. Hello. Yes, how many of you are getting this yellow mark? All?
Pin mark. Spinning mark.
Yes, yes, the spin mark, the spin mark. So from the first, you are getting a place mark. Okay. So this, yes. All are getting this place mark. So searching is done. This mark is done. Yellow mark. Okay. So now Pradeep, zoom in. Sorry, zoom out and fill the information. Zoom out. Zoom out. Now show this box, input box. Zoom out. Zoom out. Again zoom out. We are not getting this. Yes. Zoom out. Zoom out again. We are not getting this form uniformly. Some part is hiding. First cancel, Pradeep, cancel. Click on the cancel. Cancel. Click on the cancel.
Yes, sir. Correct.
Zoom out. And then search again Roorkee. Okay. Now click on this yellow mark and the information. Pradeep, what is happening here?
हेलो
हाँ प्रदीप
सर सर वहाँ पे स्लो चल रहा है सर यहाँ तो हमने खोला है
Okay, so now you are getting this information. So you can name this point and then you are getting the latitude and longitude information. Then click OK. Clear? So now we have this point. Then you click this. And Pradeep, just show me the left panel where we are getting the Roorkee area. If we are going to direct the left panel.
सर दिख रहा है ये लेफ्ट पैनल
नहीं अभी नहीं आ रहा
blue one.
Completed? Name of the place mark. Repeat. Now go with the line feature.
Okay, sir.
ये आने के बाद इसको क्लिक करना है,
Yes.
क्लिक किया, ये कुछ ओपन नहीं हो रहा है।
नहीं आप हो गया ना। हमारे यहाँ पे सब इंफॉर्मेशन सेव कर दीजिए।
अच्छा अच्छा, इससे लैंगिट्यूड और लैटिट्यूड मिले।
So this is a like how we are going to identify a particular area with their actual latitude and longitude on the global Earth. So this is a point function. Now we are going to understand the line function. Yes, so
Yes, sir.
लाइन फंक्शन शुरू करो एक बार फिर से शुरू से शुरू
Okay, sir.
वेट प्रदीप वेट प्रदीप वेट
Yes, sir.
now please line function yes थोड़ा स्लो करना है क्योंकि यहाँ डिले है थोड़ा स्लो करना so wait प्रदीप
Yes, sir.
yes This point function is clear. All are able to mark the point. Okay. Then come to the line function. Okay. So line function you can see beside the yellow pin. Third one. You can see the hand here. Click on that. Third one. Yes, Pradeep, wait.
Okay, sir.
So now you are getting this. After clicking, you are getting this. Okay, Pradeep, now we have to make a line. So we are just digitizing this road. Okay, Pradeep, start. So just click on the first point. Yes, Pradeep, you can start.
Yes, sir.
So he is making this line. You are getting this line. You are able to make. This is a line feature. First we discussed the point feature. Now the line feature.
If we have made some wrong line, how to delete that?
So just opposite that. Double click. Pradeep, just delete 1 or 2 points.
Okay, sir.
If somebody is marking as a wrong and he want to delete some points, no, not first just draw the. Pradeep,
Yes, sir.
Pradeep,
यस सर
फिर से शुरू करो उसको, पहले एक पॉइंट लगाओ फिर डिलीट करो उसी को, एक पॉइंट
Okay.
लगाओ और उसी को डिलीट करो। यस, कैंसिल कर दो उसको, अनटाइटल्ड पाथ उसको कैंसिल कर दो।
कर दिया
यस, सो वर्ड डिलीट कर दो उसको।
स्टार्ट
Yes, yes. Okay, करो उसको, okay करो। हाँ। Now you can see here what we are doing. First, we will just add a one point and then delete. Yes, first make 2 points. Okay, one more.
यस सर
Now delete these 2 points. So what you will do? So
Right.
deleting this point,
राइट क्लिक
right click. You are able to delete? Yes. You are able to delete? Yes. You are able to create? Yes. Okay. Now you can save the name any untitled path. Okay. So when we have a specific location, we will go with the point feature. When we have some road, some tunnel, or some like bridges, so we will go with the line feature. And then we have a agriculture parcels. Yes. So we have to go with the polygon. Okay. So Pradeep, please go with the polygon digitization.
Okay.
So choose some agriculture field. Yes, like this. So you can zoom out, zoom in, zoom out somewhere, and wait, Pradeep. They are doing.
Okay.
So you all are able to get this type of agriculture field.
Yes, sir.
You all?
मिल जाएगा सर, देख रहा हूँ
हाँ,
पहले कैसे
अच्छा।
करेंगे उसको।
Wait, Pradeep. Huh? So point is clear. Line is clear. Now we have to go with the polygon. Okay. Pradeep, now we start the polygon. So you have to click here, second number. Please click second number. Okay, Pradeep, wait. All click second number? Yes. Okay, now you have to digitize. You have to make points according to parcel boundary.
सैम्पलिंग एरिया
Yeah. Or we can say the annotation of a particular field. Suppose this is a rice field, this is a sugarcane field. So with the help of digitization, we can like this. Yes, so how many of you make a one parcel? So this is our one parcel. Repeat. How
Yes.
many of you completed this to digitizing of one parcel? Second number. You all are able to digitize point line polygon? Yes. Pradeep, now what settings we can do? So the first start from the style from the beginning. All are getting the white mark before, so from the setting start new. Take it new parcel again. Yes, so just digitize and then change some settings. So what settings we can apply? So you can go with the style and color. Different settings. Suppose you are getting this field, so you can select the field or outline or only outline. So you are able to visualize your field as well. You can change the color of the digitization line. You can change the size of the digitization line. Pradeep, move slowly.
Okay.
You can highlight the color. You can modify the lines, width. All are possible with this.
area also.
Okay, Pradeep. So all point, line, and polygon, three features you saved in your Google Earth Pro.
Yes.
All.
एरिया भी कैलकुलेट हो जाएगा इसमें
सब कुछ हो जाएगा पता नहीं प्रदीप
Yes, sir.
and now just showing them to create a KML file.
Okay, sir.
Actually, suppose just wait for this. Suppose this is our basic features like point, line, and polygon. Our interest is IIIT Jabalpur. Our area of interest is IIIT Jabalpur. So we need some mark on this IIIT Jabalpur boundary. Yes. So what we will do first, Pradeep, just create an area of interest somewhere. Yes, IIIT Jabalpur. Search IIIT Jabalpur. Pradeep, move slowly.
Okay, sir.
So you are getting this image, the IIIT Jabalpur. Okay. So why we are, yes, today what we discussed the satellite data. So the satellite data, our interest is IIIT Jabalpur. Okay. So we need to find out the IIIT Jabalpur from the satellite data. So what we need to do? First, we need to create a KML file from this. So he is just marking the boundary of our area of interest. You can also. It will help you the next. Pradeep, mark the boundary of the IIIT. Yes.
Okay, sir.
Anywhere you can mark. Yes, you are able to mark this. Pradeep,
Yes, sir.
make it like a rectangular, a different shape. Please make a different shape. So it is not required. You have to make a rectangle box. You can make a different box as well. So like here you can see, we can modify the shape according to our need. Like this. Okay. So we can generate our area of interest anyhow. Now Pradeep, save this.
KML.
So this untitled, yes, IIIT DM Jabalpur. Save this as a IIIT DM Jabalpur. All are able to save the IIIT Jabalpur area of interest. Yes. Anyone left? एक बार चेक कर लेना सभी. हाँ. So this IIIT Jabalpur area of interest digitized by you people. Okay, Pradeep. Now
Yes, sir.
download this area only as a KML. Please go slowly. So
Okay.
please go in the left panel where it is mentioned that area of interest IIIT DM Jabalpur or any other you have created by yourself. Then click on that, right click on that, and then save place as. Save place as. Save place as.
came that one.
Yes, you all are able to save. How many of you saved the KML file? You are getting the KMZ or KML both. Yes, KMZ. Save. All are able to save the file, the KMZ or KML format. This will help you for the next step. Okay, so please save it carefully. Now, Pradeep, close this Google Earth.
Yes, sir.
You all please close the Google Earth.
Close कर.
Please, close कर दीजिए. Now go to the saved file where you save your file and double click on that after the closing of Google Earth. Just click on double click on that saved profile. Okay, so when you click on directly, it will show you the area of interest directly. It will come. Coming. First, you need to close the Google Earth and then again click on the saved file. Clear? Okay. So now we can see our area of interest is visible here. Yes, anyone having the problem? Please let us know. Great, Pradeep. So all are able to do. I am requesting to everyone, please execute the process because it's a basic learning. It will help you in the future as well. Because it's an open source, there is no need to pay. So you can start your research. Anyone? No, nothing. Now clear? All completed? Okay, Pradeep. This is a shift. This is a KMZ or KML file, which is according to your area of interest. Okay, this is created by you. Okay, this is created by you because your area of interest is very individual. Okay, now suppose you want to analyze the entire Madhya Pradesh. You want the agriculture land for entire Madhya Pradesh. Then it is very difficult to digitize each and every boundary. So we have another facility that is called the shapefile. What we have? Shapefile, .shp file. So shapefile we can directly download freely. They are available freely. We can directly download. Okay. So Pradeep, first go to the Diva GIS. So just open your system, the Google Chrome, and type the Diva GIS shapefile. Diva GIS shapefile in the Google Chrome. Diva GIS shapefile. Diva GIS shapefile. Please wait and go slowly, please.
Okay.
Diva GIS shapefiles. Diva GIS shapefile in the search box of the Google Chrome, and then you are getting this. Yes. Then click on the data. Click on the data. Click after the clicking on the data, you are getting this window. Then you have to select the country. Diva GIS shapefile, then data. Then you need to select the country. We are interested in India, so please select the India. Then subject. Yes, all are able to do this? Yeah. Okay, fine. So here we can see there are different subject, or we can say the different area of interest. Someone is administrative area, inland area, roads, railroads, elevation. So what you want to select, you can select according to your end applications. So for the agriculture purpose, we are selecting the administrative boundary or administrative area. The first administrative area. So you are getting this India ADM.zip file. So we are getting the entire India shapefile. Okay, the map of the India shapefile we are getting. Click on that. It will download the shapefile of entire India. So wait. So now you are able to download the shapefile. That is a very important task and very different part. Okay. So can we say you are able to download the shapefile?
Yes.
Okay, fine. Now, Pradeep,
Yes, sir.
so what we have to do in the today class, what we learn the different remote sensing satellites. Yes. So remote sensing satellite, to download the data, first we need to identify our area of interest. Now you are able to select the area of interest. You can design the manually or you can directly from the shapefile. Is it? Yes or no? Okay. Then Pradeep,
Yes,
just
sir.
move to the downloading of satellite data because it will take time. So we will do both the things parallelly. Okay. So now you have area of interest. Now we are going to download the data from the freely available satellite like Landsat or Sentinel-2. So we have to write the USGS Earth Explorer in the Google Chrome. USGS Earth Explorer. USGS Earth Explorer. USGS Earth Explorer in your Google Chrome. Yes, USGS Earth Explorer in your Google Chrome. Then open the first link, the Earth Explorer USGS.gov.
Yeah.
You are able to open. Okay. Then what you need to do, you need to create an account or not. So you need to create an account. Please create an account. Pradeep, you can see the, okay, it is already created. Use your institute mail ID, it will be preferable. Pradeep,
Yes, sir.
open this URL in incognito mode. Open this URL in incognito mode. This instruction is not for you. You are doing the same thing. Okay. Yes. USGS Earth Explorer here. Pradeep. Yes. Enter. USGS Aeros registration system. You are able to register. Please create. Create your account in USGS Earth Explorer. Creative. I think it's a long form for to submit. Yes, yes. Because it's open source, na? You have to pay something like your time and your efforts.
इस सेम कैसे इंफॉर्मेशन रिसीव करेंगे, यूज क्यों करेंगे, इसलिए करेंगे इसका
डेटा डाउनलोड करना,
अच्छा डेटा
जो भी आपके जो अभी हमने सुबह डिस्कस किया
जी जी
वो से फ्रीली अवेलेबल जो भी सैटेलाइट है,
गूगल अर्थ से भी कर सकते हैं, यहाँ से भी
गूगल अर्थ से डेटा डाउनलोड नहीं कर सकते हैं,
केवल एरिया का
विजुलाइज कर सकते हैं। आपको यदि कोई बहुत माइन्यूट लेवल पर इंफॉर्मेशन चाहिए तो आप देख सकते हैं, लेकिन हिस्टोरिकल डेटा नहीं मिलता है गूगल अर्थ पे। सैटेलाइट पे आपको हिस्टोरिकल डेटा भी मिल जाएगा प्रीवियस ईयर्स का।
ठीक
If they are asking the question, so please make sure for the research and academic purpose. Education purpose. Academic to download the data. Yes, the Sentinel, Landsat we discussed that today, the open source data. So we have to download by registering this portal. Yes, anyone complete the registration?
यस सर
You are able to log in? Log in this. Yes, how many of you completed only one? From this row, anyone? Yes, sir, I can. Are you working on behalf of the yes. Peter, provide.
हाँ सर एक्चुअली वो अक्षय सर चल रही वर्कशॉप सर अपनी कॉन्टेक्ट
तो सर थोड़ा सा उसे थोड़ा सा एकेडमिक के ही रखिएगा आपको अपना
तो 5 मिनट करानी दो शीट्स में हम कोशिश कर रहे थे कि आज ही करा ले, लेकिन वर्कशॉप में भी टाइम लगा।
लॉगिन लॉगिन ले नहीं रहा है, एरर आ रहा है।
सर वो कंफर्मेशन ईमेल आया होगा आपको।
तो यहाँ मेल में
हाँ मेल।
पर इसके साथ हम लोग कोशिश कर रहे हैं अभी जैसे सेकंड सेशन शुरू कर दो और उस टाइम के साथ हम मोस्टली एक सेशन
You data you entered one or more errors. Please correct the data and try again and able to authenticate. चाहिए आप फिर से रीसेट कर लीजिए, फॉरगॉट पासवर्ड करिए। So ईमेल एड्रेस डालिए, यूजर नेम जो भी आप डाला। Give it the basic information that is not a controversial message. Because that's the use these initiatives. They are taking the question and answer in
No, sign. You already did it.
मैं अपने बोलना ये
नहीं हो रहा है सर,
रीसेट नहीं हो रहा।
ये लेने पे
हाँ नहीं सर, उसको यूजर नेम मांग रहा है, यूजर नेम बनाया होगा सर आपने।
इसी नाम से बनाया सर, मेरे डाला जी में। हाँ सेम एज इट इज डाला।
देखिए सर मेल आया होगा फिर।
ये ला नहीं रहा सर। देखिए ना एक बार इसमें, जैसे कि मान लीजिए नया बना रहे हैं, लॉगिन किया, लॉगिन जाके क्रिएट नहीं हुआ अकाउंट, जैसे कि दूसरा ही नाम डाल दे रहे हैं, प्रकाश त्रिपाठी डाल दे रहे हैं जैसे, पासवर्ड।
अच्छा सर आपसे अभी क्वेश्चन नहीं पूछे ना सर?
नहीं पूछा है सर कुछ
हाँ
भी।
तभी तो नहीं बना सर वो।
ये जैसे
बहुत
पासवर्ड,
सारे क्वेश्चन पूछेगा, 4 पेज के क्वेश्चन है इसके।
ये आगे बढ़ ही नहीं रहा सर।
हाँ तो अब बढ़ जाएगा सर। आप अपनी मेल आईडी यूजर नेम डाल दिया, ठीक है।
मेल आईडी डालूं सर? यहाँ पे क्या डालूं?
सर वैसे भी कोई इंस्टीट्यूट है आपके पास मेल आईडी इंस्टीट्यूट वाली?
है लेकिन ये इसी को डाल देते हैं,
हाँ, इसी को डाल दीजिए।
इसी को डाल देता हूँ, क्योंकि ये तो एक्सेस में है सर मेरे। मान लीजिए कुछ आएगा तो एक्सेस हो जाएगा। जैसे पासवर्ड सेट कर देते कुछ भी,
कुछ भी नहीं सर, वो ये है ना सर,
जो याद
ये
रहे।
हिसाब से रखना है।
इसके हिसाब से
हाँ।
एक्चुअली ग्रीन टिक भी हो जा रहा है। ग्रीन जैसे मैं इसमें सेट करूँ सर, ये मैंने सेट किया प्रकार सेट 56, उसको वैलिडेट कर दे रहा है, वैलिडेट
आई एम
कर
नॉट
दे रहा
रोबोट।
है। ये भी अब आया, अब ये खुला है। अच्छा नहीं खुल रहा है फिर, ये वन मोर एरर्स ऐसे दिखा।
सर एक काम करिए, इसमें इसको हटाइए, सिर्फ नाम रखिए प्लीज सिंपल
प्रकाश
सा।
त्रिपाठी डाल दो।
Must be between 4 to 30 characters. May contain alphabetical numerical character. May only contain the following special characters. Dash.
क्राइटेरिया लगभग उसकी जो है वो
ये हटा दीजिए सर, ये काम करिए,
Dot.
जीमेल हटा दीजिए,
जी मैं बता दूँ,
डॉट हटा दीजिए बस।
@ तक रखते हैं।
हाँ,
तो
बस।
प्रकाश
बस।
त्रिपाठी 19 @ कर देते
अब कर दीजिए।
हैं।
यस सर, ये सर आई हैव बस ये करीब
हो गया सर।
हाँ सर, लॉगिन कर लीजिए। लॉगिन हो गया? हाँ ठीक है, लॉगिन सही सही परफेक्ट। Anyone able to log in? Yes, from this room. Sir, log in. Okay. Ma'am, you do it? So, wait. So what we will do this task registration in the any other session. First, we can see how to process the data. So, what we can do? Naveen,
Yes, sir.
एक कोई डेटा जो तुमने डाउनलोड किया हो मुझे मेल कर दो जरा ड्राइव से.
Okay, sir.
So this registration process we will do in the next session, no problem. So what is our objective today? We will how to process the data. Okay, so I am just giving you the demo data. After the registration, you will get the verification link in your mail. Then you are able to log in. Otherwise, it will not log in. Yes. So first check your mail as well. प्रदीप.
Yes, sir.
प्रदीप.
Yes, sir.
एक काम करो, इस जो तुमने भेज रहे हो ना,
Yes, sir.
इसको क्या करो, इसको ना वो कर दो, गूगल ड्राइव पे ओपन टू ऑल कर दो, शेयर सभी के साथ कर दो, फिर मैं इसकी लिंक मुझे भेज दो उस पे व्हाट्सएप पे, ठीक है? इसको ड्राइव को कर दो, ओपन टू ऑल कर दो, इसको ड्राइव पे शेयर करो पहले, गूगल ड्राइव, हाँ ड्राइव पे शेयर कर दो इसको, अपलोड कर दो इधर पे, फाइल उठा के सीधा यहीं फेंक दो, अपलोड कर दो। ठीक है, हाँ हो जाने दो, अपलोड हो जाने दो। So after the registration, you will get a one confirmation email. You have to click on that, then your account will be logged. If you are not getting the confirmation, you are getting it. Okay. So how many of you are confirmed successfully the registration and the login? Very few. 4, 5, 6. Okay, so don't worry about that. It is a very easy process. We will do in the future as well. We are just focusing on the data. So just
इसको देख लेता हूँ सर, बाद में इसको कर दूँ।
हाँ सर, ये क्या है ना, ये आपको जब तक वेरिफिकेशन लिंक नहीं आएगी तो नहीं होगा।
क्या एक बार किया तो पैसा नेक्स्ट बार
हाँ ये ओपन है। प्रदीप,
Yes, sir.
Share. With anyone. Restricted, anyone. Please send me the link only. Copy the link and WhatsApp to me. So I will share this data with you for your experimental purpose. Okay, this login and registration account is not a big deal. You can do anywhere from this lab or after the session we can. हाँ मैं आपको भेजूँ. ये उसमें ग्रुप में पेस्ट कर दीजिएगा गूगल वाले जूम पे. प्रदीप यू कैन आल्सो पेस्ट इन द जूम. प्रदीप.
Yes, sir.
प्रदीप
Yes, sir.
जूम पर पेस्ट करो. जूम पे टेक्स्ट में डाल दो उसको. हाँ यहाँ पेस्ट कर दो.
हाँ लेकिन सर व्हाट्सएप पे भी करना ही पड़ेगा ये, क्योंकि ये सब सर ये जूम पे नहीं है.
कोई बात नहीं, मैं आपको भेज रहा हूँ.
व्हाट्सएप ग्रुप ज्वाइन किया है सबने. मेल पे भेजा है नहीं सर. व्हाट्सएप ग्रुप ज्वाइन करने का लिंक
भेज दीजिए. इसी बहाने आप लोग ज्वाइन कर लीजिए.
और चैट में डाल दिया था.
ठीक है प्रदीप. Pradeep, now show the steps to download the data. Now show the steps to download the data.
Okay, sir.
So first we just please be careful with this screen. We are going to download the data.
ग्रुप में डाला है मैंने.
प्रदीप दिख
Yes,
नहीं
sir.
रहा है. अर्थ एक्सप्लोरर नहीं दिख रहा है. इसको मिनिमाइज करो.
After registration, in which phase will be registration?
Uh,
Like when downloading data from there.
yes. Pradeep,
Yes, sir.
USGS. The Google Chrome, USGS. Yeah. So now after the login, please see here, all the participants. We are going after the login. We are getting this type of screen. So what you need to do? Please see here. So Pradeep, what you are doing first?
Sir, upload KML.
So we need to upload the shape or KML. What you are having, which is created by you or downloaded by the DGIS. So we have three options. Please click again. Oh, here. KML and KMZ. KLM. Click here. Yes. So you can upload the GeoJSON. Those who are from the computer science background. No, Pradeep. Yes, so what do you have? You have these three, the GeoJSON, the KML of KMZ that you already created, and the shapefile that you already downloaded in the IDM India. Okay, so you need to upload first the area of interest. It is your area of interest to download the satellite data. Okay, click. So you are going to select with the KMZ or shape, Pradeep?
KMZ.
KMZ. So the KMZ which you downloaded. So we are just uploading the KMZ file here. Pradeep,
Yes, sir.
log out first.
Log out.
हाँ, we have to मतलब शुरू से बताइए फिर से. Log out. Okay, this is screen you are getting.
No, sir. Sir, this is the registration which I got it after.
Okay, then click on the earthexplorer.usgs.gov. Earth Explorer. earthexplorer.usgs.gov. This is your downloading portal profile. Earth Explorer. All are getting? Okay, now Pradeep log in. Okay, please see here only, please. Okay, now you are getting this screen. Okay, so now we have to upload our area of interest. So we have to click on the GeoJSON PMS shape, the right side corner. Then we are going to upload the KMZ file. Please select a file. So he is just, please select. So he is selecting the IIIT in Jabalpur. Okay. Okay, the file is uploaded. Then click on the cancel. Okay, so now this is our area of interest. Please zoom out, zoom in on that AUI. This is our shape file, you can see. Pradeep,
Yes, sir.
you can go to the next tab. We will show in the like how to download. Just go to the next tab. But after this uploading. Yes. Okay, so now this our area of interest is coming. Yes, participants, please see here. Yes, you can see there also. So this is our area of interest is coming with you. Okay, now we have this the latitude and longitude information with all the coordinates. Okay, now we need to download the data. So the data set, we need to select the data set. So yes. So please wait, Pradeep. So we are selecting the open source dataset Landsat. Okay. So we are clicking on the Landsat and you are getting the Landsat dataset repository. The next step is Pradeep. Next step.
Yes, sir.
Okay, so now after the selection, we are searching the data set. So Pradeep, if you have any other area of interest, you can upload there. You all get that shape file? Sorry, you all are having the data?
Yes.
In your WhatsApp file? Please download it. Please download it fast.
Sir, I haven't received any mail.
Ma'am, WhatsApp mail.
I'm not
Mail.
मैम ईमेल आईडी
WhatsApp will add it in.
हाँ मेल चेक करिए ना आपको मेल आया
ठीक है प्रतीक, छोड़ दो, ये छोड़ दो, कोई बात नहीं।
ओके सर।
प्रदीप, एनीथिंग विद गूगल अर्थ, गूगल अर्थ प्रो, और कुछ बताना है इसमें?
गूगल अर्थ सर ये एरिया कैलकुलेट।
हाँ हाँ प्लीज, एक सेकंड रुक जाना, अभी रुक जाना है ना, रुक जाना प्लीज। Yes, please click on the download of the data. Then we have to see here what other features we have with the Google Earth Pro. You click on the data set, downloading the data set. You don't know?
ग्रुप बनाया डीपी, एफडीपी का ग्रुप है, उसमें है लिंक आई है।
फिर से डाल दी दूसरा पार्ट। Please download the data first. All are getting the link of the data set. Yes. Okay, Pradeep. Now show the how we are going to calculate the area in the Google Earth. Like how much area you are going to analyze.
Measurements.
So with the same polygon, like we have to calculate the parameters like different. We have area, square kilometer, kilometer. We are giving this. We are getting the information from this only. Okay. Same. That you have to click on that. Right click on that particular point. Pradeep.
यस सर।
How to edit a polygon? Click on again फिर से। नहीं ये बॉक्स कैसे आया वो बताओ फिर से। क्लोज करो इसको।
राइट क्लिक।
Right click on that left panel. ITM Jabalpur. Then properties. Then properties.
मेजरमेंट।
Then measurement. Clear? Okay. Now to process this downloaded data, please open your Google Chrome again. Open your Google Chrome. Google Chrome.
File is
Okay, that is the parallel process. Don't worry about that. Just open a Google Chrome again. Yes. Yes, in the Google Chrome, please type QGIS software download. QGIS software download. QGIS is an open source software to process the remote sensing data. In this software, we have a small Python library import profile. We can import some profile with related to the Python to perform the task files. Okay, So now download the QGIS software first. QGIS. If anyone facing the problem, please let us know. Quick, fast, because we have a limited time. QGIS software download. QGIS software download. Parallelly, you have to download the given data set on the Google Drive. QGIS software. Yes. Latest version Windows. Sir, the latest version. Offline version. You have to download the offline version, latest Windows version. Offline latest Windows version. Offline latest Windows version. This one.
Which version app download, sir?
Sir, yeah, this one.
Offline, this one.
Latest. You are able to download, sir? Yes, you are able to download. Sir, you? Yes. Yes, the latest. You are not. This one? Yeah.
टाइम ज्यादा ले रहा है.
Yes, started.
Downloading is started, but sir, due to heavy file, it's not downloading or something. It will take more time.
No, I will resume.
वो डाउनलोड हो गया सर, डाटा जो शेयर की है
वो हो गया?
GB का वो
हाँ,
ये भी 1.3 GB
हो जाएगा. This one. Pradeep, anything on the Google Earth Pro?
No, sir.
Can you show the any other Google Earth file that is having a multi-polygon, multi-line, multi-point? Please visualize this. So now you can see जो भी जिसमें डेटा काफी सारा हो वो डेटा एक ओपन करोगे.
कैमरे को खोलिए.
Sir, should I add a shape file or KML file?
KML file is okay in the Google Earth.
Okay, sir.
In the Google Earth.
आवाज आ रही है टेंशन है. हेलो
Yes. So tomorrow we have one session, so we will figure out like how to 10 to 15 minutes for this session as well. Okay. प्रदीप
सर
नहीं मिल रही है फाइल?
सर
Okay, so you can see here. Okay, please, participants, please see here in the screen. Yes, please. Please see here. So this is what we are having. This file, we have a multiple parcels. You can see the boundary line. Yes. So this is like which area, Pradeep is?
छत्तीसगढ़.
Okay, Chhattisgarh area we have. Okay, so in this, what we are digitizing, the point, line, and polygon here. So it's a very big area. Please calculate the total area of this table file. Pradeep, total area of this file. Click on the arrow. No, arrow. First click on the arrow. प्रदीप इधर 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 ये लेफ्ट में इसका पहले सब डायरेक्टली ऊपर करो. प्रदीप एरिया बताना है ना? हाँ, अब बता दो. अब इस पर क्लिक करो. So now you can see. नहीं ऊपर टोपो. हाँ, इसके जस्ट ऊपर वाले में. नहीं. हाँ, यहाँ पे क्लिक करो. हाँ, यहीं पे क्लिक करो. राइट क्लिक, प्रॉपर्टीज.
सिग्नल्स को
एक का दिखा.
क्या बोल रहा हूँ? हेलो.
So this is done by the manual digitization. We can say it's a manual digitization. We have given the name of this different polygon like the bold. Outline only. Yes. So now you can see the different parcels. Please zoom in. Sorry, zoom out. Zoom out. Yes. Now you can see the multiple parcels. Yes. So it is a digitized field for a particular Chhattisgarh area, and you are getting the each information. You can FID. Sorry. Okay, Pradeep. You are using your system.
Yes, sir.
Then come to the RGB UAV data. जो रॉ डेटा है वो एक बार दिखा दो, फिर उसके बाद ऑर्थो फोटो है वो एक बार विजुलाइज कराओ यहाँ पे QGIS में. जो रॉ फोटो जो डेटा कलेक्ट किया है यूएवी से पहले वो दिखाओ.
Yes, sir.
If you have multispectral thermal, please show us too.
Sir, RGB data है.
हाँ, RGB दिखा दो. So this is our RGB data that we collected through the UAV. So you can see the high resolution data we have. If you want to count the tree, you can easily count from the manual eyes. It is possible like this, but not the accuracy. So from the human eye, we can predict which crop is there. Okay, and then Pradeep, show the ortho photo.
Okay.
So like close this and just the raw images only. First raw images, multiple raw images. Yes. इसको बड़ा करो थोड़ा, स्क्रीन को बड़ा करो. मतलब ये हाँ. So now you can see for the same area we are collecting the multiple photos that are the overlap photos we have. Okay. After the overlap photos, how much photos we have? 304 items we have in this. Okay. Now Pradeep, show the photo of this data.
Yes, sir.
Anyone downloaded the QGIS? The ortho photo.
Yes, sir.
Some file. Yeah. Yeah. Actually, I downloaded it and file is being used. Processing. We are downloading
Pradeep,
that's like
Yes, sir.
so this is our QGIS software where we can add our raster vector layer that we will perform in this if possible download it in the same given time. So we are adding the raster layer. Okay, so with these images, small images, we are getting this complete ortho photo. Okay, zoom out, Pradeep, first. First zoom. Okay, this kind of Pradeep, again zoom out. So that data we have, like this is the complete data we have with the multiple images. Okay, then Pradeep, just upload this Landsat data.
Okay, sir.
And overlay on the map.
DYGS file.
Yes, even save file. Yes, you can. Sorry, your QGIS is still downloading. Just extend. Please extend your DYGS file, downloaded file, India IDM. Please extend the file. The shape file that we downloaded. Pradeep,
Yes, sir.
please upload the shape file on the Google Earth Pro.
Okay, sir.
Now open the Google Earth Pro. Extract the shape file. Download it, DYGS shape file. Yes, extracted.
yes, sir.
DYGS file extracted.
सर ये थोड़ी हैवी हो जाएगी, इस पे पूरी कंट्री है ना इंडिया की.
छोटी सी फाइल अपलोड कर लो जो तुम्हारे पास पड़ी हो, पूरी मत डालो, ठीक है. इसको क्लोज कर दो, दूसरा ओपन कर लो, छोटी शेप फाइल अपलोड कर दो. Yes, so now you can see the shape file that we already created for particular project. this Pradeep, can you just colorize to each and every polygon why we are doing the classification? Multiple polygon colors. Yes. So we provided the different class, the different basis color. So it's a shape file. So we are converting the shape to KML, KML to shape. If you have the KML file, you can convert in the shape file. If you have shape file, you can convert into the KML. Okay. So this is like which areas, Pradeep?
ये छत्तीसगढ़ छत्तीसगढ़
Okay, so this is Chhattisgarh. We have this data. So Pradeep, now just open the QGIS and visualize this on the map as well.
ओके
Now we are opening the shapefile on QGIS. Okay, the shapefile that you downloaded already. We are opening first in the Google Earth. Now we are opening on the QGIS open source software. So now you can see this is the entire area of our India with a different color shapefile. Not SHP, shapefile, not SHP file. Pradeep,
यस सर
यदि possible हो तो इसके पीछे मैप लेके आ सकते हो क्या?
बेस मैप सर
हाँ, बेस मैप ऐड कर दो. नहीं, वो पूरा इंडिया है, उसको QGIS है ना, इसमें ओपन करके हाँ इसीलिए वो डिले हो जाएगा. तो हम क्या करेंगे, QGIS में इसको क्लिक कर लेंगे. हमारे तरफ देवलपुर को देवलपुर क्लिक कर लेंगे, बाकी छोड़ देंगे. तो जब जैसा इंटरेस्ट होगा वैसा. प्रदीप,
यस सर
हाँ, इसमें वो हमारी जो शेप फाइल है जो हमने डाउनलोड करी है वो ओपन कर दो जरा एक बार. हाँ प्रदीप,
यस सर
सॉरी okay, Pradeep, go it again and upload the shape file again.
ओके सर
Remove the shape file. I think just close this software first. Close the software and do it again. So for this you can record also, but it is also recorded. So now you have to just open the QGIS. Now you are going to add the layer. Okay, then you can create any project and then go to the adding the layer. So layer, the first third number icon, the layer, then add layer, then add vector or raster, whatever you have, then add raster or vector. So we are adding the vector layer, this shape file. So raster and vector, you understand? This IMG file is our raster and this is a vector file. Okay, now upload the shape file to the entire India. So go slowly so they can just select what file they need to select. Okay, so yes, then so how many files you selected? 3 files, na?
फोर सर
Now you are able to see entire India.
आज उधर जाना सॉलिड बीच वाले
Pradeep,
Yes, sir.
now just give me the shape file of Jabalpur or Madhya Pradesh. Just go with the Madhya Pradesh only. This is our Madhya Pradesh. You can see. This is the administrative boundary of Madhya Pradesh, and we need to clip from the entire India. Our area of interest is Madhya Pradesh, so we are clipping from the India to Madhya Pradesh. Is coming to Madhya Pradesh. Install branch. Please check installation is possible to do it. Yes, so he is highlighting the Madhya Pradesh only. So now we are able to download this, we are able to clip the Madhya Pradesh, or we can say our area of interest. So there is no need to digitize manually. We are just getting directly the shapefile. Pradeep, after this, convert the shape to KML and KML to shape.
Okay, sir.
Put this file first,
Yeah.
save file or
Convert. Payment.
It is fine.
Download it or not? Yes. प्रदीप,
Yes, sir.
ऐसा करते हैं, अभी रुक जाते हैं क्योंकि QGIS इंस्टॉल नहीं हुआ, ये लोग करेंगे तो बेटर रहेगा, है ना?
Yes,
नहीं
sir.
तो इनको मिलेगा नहीं ये दोबारा.
Okay.
What is the time?
1:15.
Okay, so our lunch is started now. Okay. We will move for the lunch. Okay, in the same visitor hostel, and then again 2 will be joining here. Okay. So we will do this remaining exercise in the tomorrow session. Tomorrow I have a lunch session. So with the Google Earth Engine and the remote sensing, both we will do. Because QGIS is required. Otherwise, it will not help you to understand. Like we will do, but it will not help you to do in your personal lab or somewhere. Okay, Pradeep, thank you for your cooperation, and we will meet again. Okay.
Bye.
Thank you, everyone, and please move for the lunch. So, yes, it will be. So, what I'm thinking that as yesterday, someone is most of the people.